Okay, we turn our attention back to graphing lines again, and some people call this slope-intercept method or form of graphing a line the shortcut method for graphing lines. And quite honestly, after you've learned to graph using this method, you pretty much don't want to go back to XY charts anymore. But I will caution you, don't forget the XY charts. They're at the core of what's going on when you're graphing. Okay, here are the 3 steps. I'll let you read yourself when you go through to draw your line. Let's just go straight on to our first problem. The first thing we do is we identify and plot the y-intercept. We see here that b is equal to -3, and that tells us we're going to have a point on our graph, a y-intercept at 0, -3. We also see that then the slope is 2/5, and that tells us we're going to rise 2 and run 5. So there we go, up 2 and 1, 2, 3, 4, 5 to the right. There's our second point, and through them we draw our line. And that's all there is to it. Let's move on to the second problem. We notice that there is a y-intercept of +2. That tells us 2 units above the origin we can plot our first point. We then see a slope of -1/3, which tells us to go down 1 and over 3 to the right. There's our second point, and through them we can draw our line. Problem number 3. Plot the y-intercept. The y-intercept here is 3, so 3 units above the origin we have a point, and then we have a slope of -1, so down 1 over 1. And if you want to keep on going down 1 over 1, down 1 over 1, you're welcome to help give you more points to latch on to, or you could just just have those first 2 points and you're good to go. Problem number 4. Y equals -2. Now before we learned that we had a horizontal line whenever we had y equals. I'm going to show you that we could think of this as y equals 0x minus 2. And that way we'd have a y-intercept of -2, and since the slope is 0, it's a horizontal line running parallel to the x-axis. In problem number 5, y equals x. There's technically a y equals 1 in front of the x, then a plus 0 at the end. So with the plus 0 tells us the y-intercept is 0, and it's going to go through the origin. And then we're going to rise 1 and run 1 from there, and we're going to have a line that cuts perfectly through the first and third quadrants. This line actually has a name. It's called the identity line. Now, in problem number 6, we don't have our line in slope-intercept form. You really have 2 choices. Choice number 1, since it's in standard form, graph using the intercepts method. Personally, that's my choice. If we let x be 0, we have 4y equals 12 left, and dividing each side by 4, we get y equals 3. And if we let y be 0, we have, let me cover that up, -3x equals 12. Dividing each side by -3, we get -4. And we have 0, 3, and -4, 0. And that's all we need to draw our line. Now, if you really insisted upon going with the slope-intercept method, let's see what would happen. We would solve this equation for y, beginning by adding 3x to each side of the equation. That would give us 4y equals 3x plus 12, and then dividing each side of the equation by, let me slide that up, dividing each side by 4, we would then have y equals 3/4 x plus 3. Notice that 3 is our y-intercept. Now if we rose 3 and ran 4, that point that we would be getting to is still on our line. If we kind of backtracked our numbers back to that x-intercept and went up 3 and over 4, you can see that this is consistent with what we've been working with.